Hello everyone, I am Preet Sheth. I am pursuing my Masters in Construction Engineering and Management at CEPT University. In the second semester studio, that is Construction Project Execution, Monitoring and Control, a commercial project was undertaken. This studio mainly focuses on the execution part of the project cycle. The topics covered in this portfolio are site layout analysis, reinforcement planning, linear responsibility chart, EOQ models, risk analysis in Primavera, value stream mapping, and finally the key learnings or outcomes from each topic. So talking about the general details of the project, the type of project is a commercial project. Then there are two towers in the project as we can see in the model, Tower A and Tower B. Tower A consists of 12 floors and Tower B consists of 6 floors. Then the type of contract for the project is lump sum contract on square feet basis with material and labor. Then the project start date was 2nd February 2021, and as per the contract document the project duration is 24 months and the cost of the project is rupees 110 crores. Also, as we can see here that the site is located on SG highway near Jagatpur village, and some of the key features of the project are the plot area, which is 13,306 square meters, built up area, which is 1,10,000 square meters, and some of the unique features include a glass bridge and skywalk in Tower A on the 12th floor and the tallest man-made waterfall on Tower A. So talking about the site layout analysis, in site layout analysis, we first prepared the current site layout, and here as we can see in the current site layout, here is the Tower B, Tower A, the labor colony, labor toilets, the scrapyard, shuttering yard. This is the area for bar cutting and bar bending. Here is the area for steel storage, and here as we can see are the series of offices from the contractor side. After preparing the current site layout, we did site layout critics in which the drawbacks or flaws related to the site were identified, and one of the major drawback which was identified was the location of labor toilets. So the laborers are generally working here in this area, and to go to the toilet they have to travel a long distance, and so the correction or measure which we have provided is that the change of labor toilet and the proposed labor toilet which can be placed here as we can see on the site. And based on the various site layout critics, we have prepared optimized site layout, and in optimized site layout the major changes which have been done are the labor toilet, the location of cement or material go down, and the PMC office. And based on the current site layout and the optimized site layout, path of travel analysis has been done, and path of travel analysis basically helps us to understand that how much time is reduced by using the optimized site layout. Now talking about reinforcement planning. In reinforcement planning, we first calculated the steel required for tower beam. Tower B is divided into 4 pores, pore 1, pore 2, pore 3 and pore 4, and the steel required for each pore is calculated as follows. Now the peak requirement of steel is calculated, and to calculate the peak requirement of steel from the dates of pore planning, the steel required from September 2021 to February 2022 has been calculated, and it is found that the peak steel, like that is the peak requirement of steel, is needed in January 2022, which is 88,613 kgs. Now to suffice the peak requirement of steel, the area required for steel is calculated based on these calculations, and it is found that the total area required to store 88,613 kgs of steel is 44.8 square meter, and the area provided on the site is 79.52 square meter, which is sufficient. To calculate the labor productivity, the steel required for ground floor slab for each pore has been mentioned here. And to calculate the labor productivity for each floor slab in different pores, total 22 labors are involved, out of which 4 are for bar cutting and bar bending, 1 foreman, 11 fitters, and 6 helpers are there. So let's take an example of pore 1 ground floor slab. So the total steel required is 14,419 kgs. Then the days required for reinforcement placement are 6, and here out of the 22 labors, 4 are for bar cutting and bending, so total 18 labors would be there for placing reinforcement. So the productivity is calculated as 14,490 divided by 6 divided by 18, which gives uses 134 kgs per labor per day, and assuming that there are 8 working hours in a day, to calculate the productivity of labor per hour, this 134 is divided by 8, which gives us 17 kgs per labor per hour. And also direct cost for reinforcement is calculated. So here as shown that for core 1, the cost of reinforcement comes out to be rupees 64 lakh 3614, and similarly for all the 4 cores the cost is calculated, and the total cost for reinforcement for tower B comes out to be rupees 2 crores 18 lakhs 87,461. Moving to linear responsibility chart. Linear responsibility chart is a part of quality management, and it is a representation of the extent of participation of project stakeholders for any activity or any particular decision. It is an array of symbols here, as we can see, which explains the relationship between the different activities and the different stakeholders involved. We have totally identified total 27 activities and divided them into three categories. The first is quality planning activities, second is activities related to material inspection, and third is activities related to quality execution work. And various legends are used for different responsibilities, supervision, etc. So taking an example of quality planning activities, under that the activity selected is preparation of quality assurance plan, QAP. So from the linear responsibility chart we can see that it is the actual responsibility of the site quality engineer and the quality manager from the contractor side to prepare the QAP. Then I'm sorry, then the project manager from the contractor side may be consulted for the same, and also the project manager from PMC may be consulted from the same, and it is the responsibility of the site engineer from PMC to have general supervision for the same. And similarly, these two activities are there for material inspection and quality execution work respectively. Now talking about the various models of EOQ, which is economic order quantity. These EOQ models are a part of inventory management, and there are four EOQ models. First is the simple or classical model, then is the EOQ model with price break, the third is the EOQ model with planned shortage, and the fourth is the EOQ model with reorder point. Here we will be discussing two models. The first is the EOQ model with price break. So in EOQ model with price break, the different purchase prices of steel were captured from August 2021 to March 2022, and the graph was plotted for the same. And from the model or the graph we can say that there is a direct relationship between the total cost and purchase price of the steel. Like as the purchase price of the steel increases, the total cost also increases, and there is an inverse relationship between economic order quantity and purchase price of the steel. Now coming to the model EOQ with planned shortage. In the model EOQ with planned shortage, it is assumed that shortage will occur, and to maintain the shortage, what should be the amount of inventory that should be stored is done in this model. And so from these various calculations and model, we can say that to avoid excessive shortage cost, an optimum level of 29 ton should be maintained at site, and a maximum of 61 ton can be stored at site. Talking about risk analysis, the first point in risk analysis is the risk management cycle. The risk management cycle includes risk identification, risk analysis, risk evaluation, various mitigation measures which can be used or applied on the risk, and once the mitigation measures are applied, the monitoring and control for the same. So in the exercise of risk analysis, software called Primavera Risk Analyzer was used, in which a risk register was prepared which contains 30 risks, and the risk was calculated on the basis of PERT, which is program evaluation and review technique, and based on Monte Carlo simulations and Latin hypercube simulations, various graphs were generated. Talking about the first graph, which is a duration distribution graph. From the duration distribution graph we can say that this yellow arrow which is there, it shows that there is 52% probability that the project would get completed in 613 days. And talking about the second, which is the tornado graph. Tornado graph tells us the impact of one particular activity on the entire project. So from the tornado graph of duration sensitivity, we can say that the activities related to basement 3 will have maximum effect on the project duration, which is around 37%. And finally, a comparison was done between the two techniques, CPM, which is the critical path method, and PERT, which is the program evaluation and review technique. Critical path method basically works on the deterministic approach, and PERT basically works on the probabilistic approach. Now talking about lean construction, under lean construction, the first tool which we had applied on site is VSM, which is value stream mapping. And value stream mapping, it helps in identifying the waste in a sequence of activities, and it ultimately helps in reducing the cycle time for the scope of work. The flow of VSM is as follows. First, the current state map is prepared, then different waste are identified as per Shingo, which is downtime, defect, overproduction, waiting, etc. Then various lean tools are applied and the elimination of waste is done. And finally, the future state mapping is prepared. So the activity which we selected was casting of U blocks, and we did observation for two batches. Batch 1 which consisted of 103 blocks and batch 2 which consisted of 104 blocks. So this is the methodology for casting of U block, and from the observations taken during entire day, we found and prepared the current state mapping. And from the current state mapping, we can say that the total duration of the selected activity was 484 minutes, out of which the VA, which is the value adding time, it was only 154 minutes, which was 34%. Also, the non-value adding activity but necessary, which is the MUDA or waste type 1, was 60%, whereas the waste, which is MUDA type 2, was 25 minutes, which is 6%. Once different waste have been identified and the current state mapping is prepared, various lean tools such as Kaizen burst, pull planning, and 5S were applied to reduce the non-value adding time. And finally, the future state mapping was prepared as shown here. Different various Kaizens were used for different activities, and taking one of the example which is applied here in tool mobilization, the Kaizen one, that the mobilization of tools which can be done in advance. So Kaizen basically means continuous improvement, and by using this Kaizen burst and various other tools, the time was reduced. And so from the futures mapping, we could say that the cycle time was reduced to 303 minutes, out of which the value adding time was 154 minutes, 58%, and the non-value adding time type 1 was 113 minutes, 42%, and NVA type 2, which is the waste, was completely eliminated. And after performing VSM, the summary table which was prepared can be seen as follows, that the lead time was reduced from 484 minutes to 303 minutes, and the main change was in NVA, which is a non-value adding time, which reduced from 294 minutes in current state map to 113 minutes in future state map. Now, finally, moving on to the conclusion or the key learning outcomes. First, in site layout analysis, the site layout was prepared for the site, a 2D site layout, and also in Revit, a 3D layout was prepared for the site, and the risks on the site, the wastage on the site, and site layout critics was done. And based on that, the optimized site layout was prepared, and based on optimized site layout and current site layout, path of travel analysis was done. In pore planning reinforcement, first of all, the reinforcement requires for different pores for tower B was identified, and based upon that, the peak requirement of steel was calculated, and the area required to store the peak requirement of steel was calculated, and also the labor productivity was calculated, which helped in identifying the quantum of work which is done by laborers on the site. Now moving to the linear responsibility chart, which was the part of quality management, it helped in understanding the roles and responsibilities and involvement of various stakeholders for different categories and different activities. EOQ model. In EOQ model, two models were prepared. The first was EOQ model with price break, which helped us in understanding the variation in EOQ with respect to purchase price of steel. And second model, which was the EOQ model with plant shortage, it helped in understanding the determining optimum quantity of stock required to avoid shortage at site. In Primavera risk analysis, 30 risks were identified and a risk register was prepared in Primavera risk analyzer, and the calculation of risk was done based on PERT, which is program evaluation and review technique, and comparison between the two methods, critical path method and PERT was done. And finally, VSM, value stream mapping, which is a lean tool, it was applied on the site for the activity of manufacturing of U block. And finally, various lean tools were applied, and in the future state mapping, the total lead time was reduced by eliminating most of the non-value adding time. Thank you.